Hello and welcome to Astronomy Daily, your cosmic connection to the stars and beyond. I'm Anna, and today we're exploring some truly mind-bending stories from across the universe. Coming up on today's show, we'll witness a celestial joust between two massive galaxies on a collision course, with one firing a beam of radiation through the other like a knight's lance. We'll also discover that Jupiter, the architect of our solar system, was once twice its current size with a magnetic field 50 times stronger than it is today. Then, we'll examine the often overlooked challenges of interstellar travel. Not the rockets and propulsion systems, but the microscopic passengers that would need to make the journey with us. Plus, we'll explore one of the strangest planetary systems ever discovered, featuring a planet that orbits perpendicular to everything we thought we knew about orbital mechanics. And finally, we'll check in on Tom Cruise's ambitious plans to become the first actor to film a movie in actual outer space. It's a packed episode exploring the biggest and smallest wonders of our universe. So let's dive right into today's Astronomy Daily. Astronomers have recently observed what they're describing as a cosmic joust, two massive galaxies hurtling toward each other in deep space. This remarkable celestial event gives us a glimpse of a galactic merger as it was happening 11.4 billion years ago, when the universe was just about 1/5 of its current age. The observation, made using two powerful telescopes in Chile, the Atacama Large Millimeter Submillimeter Array, and the European Southern Observatory's Very Large Telescope, reveals two galaxies, each containing roughly the same number of stars as our own Milky Way. But what makes this encounter particularly fascinating is what's happening at the heart of one of these galaxies. One of the galaxies contains a quasar, an extraordinarily luminous object powered by a supermassive black hole. As gas and other material fall into this cosmic monster, it heats up due to friction, creating a disk that emits extremely powerful radiation in two opposite directions. These are called biconical beams, and one of them is directly piercing through the companion galaxy. The researchers have likened this interaction to medieval knights charging toward each other in a joust. As astrophysicist Sergei Balashev from the IOFA Institute in St. Petersburg puts it, one of them, the quasar host, emits a powerful beam of radiation that pierces the companion galaxy, like a lance. This radiation lance is actually disrupting the molecular clouds in the companion galaxy, the very clouds that would normally give rise to new stars. Instead of forming stars, these clouds are being transformed into tiny, dense cloudlets that are too small to create stellar nurseries. It's effectively wounding its opponent by disrupting the gas structure necessary for star formation. The supermassive black hole powering this cosmic joust is estimated to be about 200 million times the mass of our Sun, far larger than the one at the center of our own Milky Way, which is only about 4 million solar masses. What makes this observation particularly special is that it's the first time scientists have witnessed this kind of phenomenon, a quasar's radiation directly affecting the molecular clouds in another galaxy. The unique alignment of these galaxies from our perspective on Earth allowed researchers to observe the radiation passing directly through the companion galaxy. According to astronomer Pasquier Notre Dame of the Paris Institute of Astrophysics, these two galaxies will eventually coalesce into a single larger galaxy as their gravitational interaction continues. The quasar will gradually fade as it exhausts its available fuel. Most galactic mergers observed by astronomers occurred later in the universe's history, making this early cosmic collision particularly valuable for understanding how galaxies evolved in the young universe. It's a dramatic snapshot of the violent processes that have shaped the cosmos since its earliest days, a cosmic joust that will ultimately end in union rather than victory for either contestant. Next, let's take a new look at one of our cosmic neighbors. Jupiter, the largest planet in our solar system, was once even more massive and magnetically powerful than it is today, according to a groundbreaking new study published in the journal Nature Astronomy. Researchers from Caltech and the University of Michigan have determined that approximately 3.8 million years after the formation of the solar system's first solids, Jupiter was about twice its current size with a magnetic field 50 times stronger than what we observe now. This revelation comes from an ingenious approach that bypasses traditional uncertainties in planetary formation models. Rather than relying on assumptions about gas opacity or accretion rates, the researchers focused on something more concrete: the orbital dynamics of Jupiter's tiny moons, Amalthea and Thebe. These small moons, which orbit even closer to Jupiter than the Galilean moon Io, have slightly tilted orbits. By analyzing these orbital discrepancies, Konstantin Batygin, professor of planetary science at Caltech, and Fred C. Adams, professor of physics and astronomy at the University of Michigan, were able to calculate Jupiter's original dimensions. Their findings paint a picture of a truly enormous early Jupiter, with a volume equivalent to over 2,000 Earths. This isn't just an interesting factoid. It provides critical information about a pivotal moment in our solar system's development. The research establishes a clear snapshot of Jupiter at the precise moment when the surrounding solar nebula evaporated, effectively locking in the primordial architecture of our solar system. Our ultimate goal is to understand where we come from, and pinning down the early phases of planet formation is essential to solving the puzzle, explains Batygin. This brings us closer to understanding how not only Jupiter, but the entire solar system took shape. What makes this research particularly valuable is that it provides independent verification of long-standing planet formation theories, which suggest that Jupiter and other giant planets formed via core accretion, a process where a rocky and icy core rapidly gathers gas. These theories have been developed over decades by many researchers, including Caltech's Dave Stevenson, and this new study adds crucial specificity to our understanding. Understanding Jupiter's early evolution has broader implications for our solar system's development. Jupiter's gravity has often been called the architect of our solar system, playing a critical role in shaping the orbital paths of other planets and sculpting the disk of gas and dust from which they formed. As Fred Adams notes, it's astonishing that even after 4.5 billion years, enough clues remain to let us reconstruct Jupiter's physical state at the dawn of its existence. While Jupiter's very first moments remain obscured, this research establishes what Batygin calls a valuable benchmark, a point from which scientists can more confidently reconstruct the evolution of our solar system, bringing us closer to answering fundamental questions about our cosmic origins and the processes that made our planetary neighborhood what it is today. Our next story today features a subject I know many of us wonder about. When we think about interstellar travel, our minds typically gravitate toward the technological challenges of propulsion systems and spacecraft design. But according to physicist and author Paul Davies, we're overlooking perhaps the most critical obstacle to human space exploration beyond our solar system, the complex biological requirements for creating a sustainable ecosystem. In Davies's analysis, traveling between stars will inevitably be a one-way journey, even with the most optimistic technological advances. This means any mission would require creating a completely self-sustaining ecological environment. It's not simply about growing enough food and generating oxygen. It's about replicating Earth's intricate web of life on a cosmic scale. The true complexity lies in the microbial realm. As Davies points out, almost all terrestrial species are microbes, bacteria, archaea, and unicellular eukaryotes, and they form the foundation of Earth's biosphere. These microorganisms aren't merely passengers on our planet. They're essential components of our life support system, recycling materials and exchanging genetic components in ways we're only beginning to understand. Even within our own bodies, microbes play a crucial role. Your personal microbiome, the microbial inhabitants of your gut, lungs, and other organs, outnumber your own cells. Without them, you would die. So astronauts cannot journey to the stars without, at minimum, their own microbiomes. But it gets even more complicated. Microbes don't exist in isolation. They form vast networks of biological interactions that remain poorly understood. There's horizontal gene transfer, cell-to-cell signaling, viral interactions, and collective organization that creates an ecological web of staggering complexity. Scientists have barely begun to map this intricate planetary-scale information flow. This raises what Davies calls a Noah's Ark conundrum with a vengeance. Which species get chosen for the journey? What is the minimum complexity of an ecosystem necessary for long-term sustainability? At what point does removing certain microbes cause the entire system to collapse? The problem is that we simply don't know. We haven't identified the smallest self-sustaining, purely microbial ecosystem, let alone which microbes are crucial for human survival in space. Imagine compiling a list of plants and animals to accompany humans on a one-way mission: cows, pigs, vegetables. But then consider how many and which microbial species these organisms depend on, and which other microbes those microbes depend on. Space conditions add another layer of complexity. Research shows that bacteria can change their gene expression in zero gravity. Michelle Levin's experiments with planaria worms that had flown on the space station revealed that some returned with two heads instead of the normal one. How might other organisms change in the harsh environment of space? Davy suggests our best hope may lie not in cataloging genes, but in discovering the underlying principles governing the flow and organization of information in living systems, what he calls the software of life. If we can identify universal informational patterns in biology, we might create a transplantable ecosystem robust enough to withstand space conditions. Without solving these fundamental biological challenges, our dreams of establishing permanent human settlements beyond our solar system may remain just that, dreams. The tiniest organisms may pose the biggest obstacles to our cosmic ambitions. Next up today, will the cosmos ever stop surprising us? I hope not. In what might be the most unusual planetary arrangement ever discovered, astronomers have recently identified a system that defies our conventional understanding of how planets form and orbit. The system, informally known as 2M1510, features what appears to be a planet tracing an orbit that carries it directly over the poles of two brown dwarfs that are orbiting each other. If you're having trouble visualizing this, imagine two spinning tops circling each other on a table, while a marble rolls around them in a path that goes over and under the table. It's a configuration that until now existed only in theoretical models. In typical planetary systems, like our own solar system, planets orbit their stars in a relatively flat plane that aligns with the star's equator. This makes sense because planets form from the same rotating disk of material that formed the star. Everything stays nice and orderly, moving in roughly the same plane. But candidate planet 2M1510b breaks all these rules. Its orbital plane appears to be perpendicular, at a 90-degree angle, to the plane in which its two host brown dwarfs orbit each other. Brown dwarfs themselves are fascinating objects, too massive to be considered planets, but not massive enough to sustain the nuclear fusion that powers stars. They're cosmic in-betweeners, and this system has two of them at its center, with a third brown dwarf orbiting at an extreme distance. The detection method for this perpendicular planet is itself remarkable. Most exoplanets today are found using the transit method, where we detect tiny dips in starlight as planets cross in front of their stars. But that wouldn't work in this unusual orbital arrangement. Instead, researchers used what's called the radial velocity method, measuring subtle shifts in the brown dwarf's light spectrum caused by the gravitational pull of the orbiting planet. More specifically, they detected how the planet subtly alters the 21-day mutual orbit of the brown dwarf pair. After extensive analysis, the research team concluded that only a polar orbiting planet could explain these perturbations. This discovery is significant because circumbinary planets, those orbiting two stars at once, are already quite rare. Of the more than 5,800 confirmed exoplanets, only 16 are known to orbit binary systems, with most discovered by NASA's now-retired Kepler Space Telescope. A circumbinary planet in a polar orbit takes this rarity to another level entirely. Scientists have previously observed debris disks and protoplanetary disks in polar orbits, which led to speculation that polar orbiting planets might exist. 2M 1510 appears to be the first confirmed case, validating these theoretical predictions. The international research team, led by Thomas A. Baycroft from the University of Birmingham, published their findings in the journal Science Advances in April, with the planet officially entered into NASA's Exoplanet Archive on May 1st of this year. This bizarre system challenges our understanding of planetary formation and orbital dynamics, suggesting that the universe has many more surprises in store as we continue to explore the cosmos. It reminds us that nature often finds ways to create arrangements far more exotic than what we might imagine. Finally, today, this news will horrify some and delight others. In the realm of space exploration, one unlikely pioneer may soon make the transition from movie star to actual astronaut. Tom Cruise, known for performing his own death-defying stunts in the Mission Impossible franchise, appears to be inching closer to perhaps his most ambitious project yet: filming a movie in actual outer space. According to Cruise's IMDb page, an untitled Tom Cruise SpaceX project is currently listed in pre-production. The tantalizing description states that Cruise and director Doug Liman plan to travel far beyond Earth to film the first ever Hollywood motion picture in outer space. While no official launch date has been announced, this development suggests the long-rumored space movie may indeed be moving forward. The concept first gained traction back in 2020 and 2021, following a successful SpaceX NASA rocket launch from Cape Canaveral. NASA confirmed at the time that they were in discussions with Cruise about filming a movie aboard the International Space Station, though updates about this potential collaboration have been scarce since then. Interestingly, during SpaceX's Inspiration 4 mission in September 2021, the four-person civilian crew, which included Jared Isaacman, who would later become President Trump's pick to lead NASA, actually spoke with Cruise via a Zoom call during their orbital flight. At that time, reports suggested Cruise was set to fly on a different Crew Dragon mission to film scenes for an upcoming movie. While Cruise would be the first Hollywood actor to film in space, he wouldn't be the first to shoot a feature film there. That distinction belongs to Russian actress Yulia Peresild and director Klim Shipenko, who traveled to the International Space Station in October 2021 to film scenes for The Challenge, a drama about a surgeon sent to space to save a cosmonaut suffering from a heart attack. Released in 2023, it became the first feature-length film with professional actors shot in space. For Cruise, who turned 63 this year and is fresh off the success of Mission Impossible: The Final Reckoning, a journey to space would represent the ultimate frontier in his career of pushing physical boundaries. The actor has already hung from airplanes, scaled the world's tallest building, and performed halo jumps from extreme altitudes. Space would certainly be the next logical, if extraordinarily ambitious step. Whether this project ultimately launches remains to be seen, but one thing seems certain. If anyone in Hollywood has the determination and influence to make filming in space a reality, it's Tom Cruise. And that wraps up another incredible journey through the cosmos on today's episode of Astronomy Daily. From those two galaxies engaged in a cosmic joust billions of years ago, to Jupiter's surprisingly massive past, to the complex microbial challenges of interstellar travel, the universe continues to amaze and humble us with its mysteries. We also explored that fascinating perpendicular planetary orbit in the 2M1510 system, a configuration astronomers had only theorized until now. And of course, Tom Cruise's potential journey to become the first Hollywood actor to film in actual space certainly pushes the boundaries of what's possible when human ingenuity meets cosmic ambition. The universe is vast, mysterious, and full of stories waiting to be told. If you want to stay on top of all the latest developments in space and astronomy, I encourage you to visit our website at astronomydaily.io, where you can sign up for our free daily newsletter. Our site features a constantly updating newsfeed with the latest discoveries and breakthroughs in cosmic exploration. Don't forget to subscribe to Astronomy Daily on Apple Podcasts, Spotify, YouTube, or wherever you get your podcasts to ensure you never miss an episode. This has been Anna, your guide to the cosmos, and I'll be back tomorrow with more fascinating stories from the final frontier. Until then, keep looking up.